So we talked about on Friday a little bit how to read data, right? How to select and query the database once you get data in there. So part of what I want to talk about here is how we get data in there in the first place, as well as how we manipulate the data that's there. Turns out that part's actually pretty simple, at least from an introductory level. It'll get more complicated as we get more complicated applications. But for now, we're going to kind of keep this simple, use some pretty simple statements as far as Crud goes. So let's talk about what Crud is, because that's a really important part in this course as a whole. So Crud is an acronym, and it's really commonly used when we're talking about databases, web applications, and user interfaces, which is really bread and butter for this course. Okay, so you're going to see this come up all the time. This is not the first last time that you're going to. This is not the last time that you're going to see this term. Okay, because what we're in the end wanting to build is web apps that can do Crud. Okay. But we're just kind of slowly building our way there, starting from the database layer, working up to the application layer, talking about APIs, and then finally getting to the user interface portion of that. Okay, so we're kind of building up towards the front end. But this is a really important term to understand there. So this is an acronym. Okay, you really want to remember what this acronym stands for. It stands for create, read, update, and delete. Okay, you'll see this all the time in the industry. It's a commonly understood term. Okay, and so where does that fit in? Well, basically anything that we build, as I was saying, databases and web applications and user interfaces can often be described in these terms. Okay, so when we say create, we're creating data. Okay, we're putting data into the database. Other verbs you sometimes see there is add or insert. Okay, those are also things you might see, or sometimes you see the term append. Okay, all of those would be instances of creating. You're making new data. If you think about your object-oriented background, if you think about creating a new object, you're creating a new thing, right? So that's kind of what that's tantamount to that. Next thing you have read. Read is actually pretty broad. It's anytime you want to read data, do anything with it. There's some merit to saying that read, maybe there should be a few more letters in there to really justify what read means, because read is usually a lot more than the other three letters, meaning that you have different kinds of reading. Like you might read an individual record, you might read an individual user from the database, or you might read all of the users from the database, right? Both of that falls into the read classification because you're reading data. You also might have cases where you're searching for users, like maybe users that have the last name Smith. That would also be a read operation. So that includes getting all the data, that includes getting some of the data, or even just getting a single record. Okay. In reality, you'll find that in most web applications that you spend probably more than half of the time on the read portion of this. Okay. You're actually going to find that you spend most of the time right here. Okay, is kind of the current world of web development. Is reading data is often a lot more important and a lot more complex than some of the other operations are. Updating data would then be say, hey, there's a record in here and I want to change that one record. Okay, like I want to reset my password. Well, that would be an update. I've been changing the data. My date of birth, maybe I put in the wrong date of birth, and change it, fix it up, additional data I need to put in there, right? So this includes modifying data, this includes changing data, but update is kind of the generic term that we use there. And then finally we have deleting data, would say, I want to get rid of this data. I want it to be gone permanently. Now, in some cases, we might instead deactivate the account or deactivate the record in some way that it's hidden, right? I think when we did the bug tracker, we did closed the bugs, and then they become being hidden, but the data wasn't lost, right? So that's a common thing to do as well, is maybe you don't necessarily delete the data, but you hide it. So that can be covered by this as well. common verbs you see there: delete, destroy, deactivate, etc. So there's a lot of different things that can fit in there. Okay, there's a lot of different variations, in fact, that people have suggested to Crud, because there's some, some things that have happened and some things that maybe need more clarification. So these really aren't very popular acronyms, but they've been suggested as maybe enhancements, as you might say, to those ones. For instance, you have CRUDL, which just adds the term list. Problem being is it's often not clear that with the read that you really need to support a list of things and also to be able to read a single record. Some sort of list of records plus reading a single record. So that's what that's clarifying. You might also see the term bread, B for browse, as if you're searching for data, reading, edit, add, delete. Dave, delete, add, view, edit. Crap, create, replicate, append, or process. There's a lot of different ways to write this out, but CRUD is the most common one that we kind of see in industry. I would argue that CRUDL is probably a little bit of a better acronym because that list gets forgotten all the time, but it's not really the one that we use most commonly in the industry. So an example that you might see of this, say we've got the address book. If you want to build an address book application and say make it valuable to your users, you really do need to support the full set of CRUD verbs, right? If you don't have any of these pieces of functionality, your app's not really fully functional. It's not really something that a customer wants to buy because it's missing something fundamental. So we might say, hey, things that the address book needs to be able to do. We need to be able to create records or add new contacts, right? We need to add contacts to my address book. I need to be able to search that contacts. I need to be able to view the contacts that are in there. And I may need to update or edit those existing contacts, or I might need some way to delete or remove contacts at some point. Once I have all that, then I basically have a functioning address book. Does that make sense? But if I'm missing one of those key parts, I don't really have a working address book, right? If I can create records, but I can't search the records, well, what's the point? If I can't view the data, it doesn't matter that the data's there. If I put an address in there, well, addresses change all the time. So I do need to be able to update them when they get a new phone number, or when they move, or get married, or whatever the case is. There's a lot of reasons it might trigger an update. Okay? Or things happen. I don't want to necessarily keep all my contacts forever. That would get pretty noisy. So at some point I need to be able to delete. Okay? So that's kind of where that fits. And so you can tie it back to your user interface. So in general, this term CRUD can really be applied to any kind of persistent storage. Okay? Any kind of persistent storage can be thought of in CRUD. Okay? It has to be something that's implemented there. So that means this applies even to things like your file system, your database, whatever it may be. That's what we need. Okay. So we say, as far as this goes, data can be put into a location or area of persistent storage. Okay. So if we're thinking about a file system, that would be a file, or you could be talking about directories, or you could be talking about a database where you're talking about a single database record. You can actually even talk about it in terms of memory and say these things are objects, right? These are objects that you're creating and destroying. Okay, well, we could think of it there as well. So whatever it is, the content of a storage location needs to be both readable and updatable in order to really have it be valuable as a storage location. I need to be able to read the data as well as update the data. In order for that location to be read or updated, obviously it needs to be created first, right? If I'm going to store this somewhere, I have to have that place, that storage place, created first. And so oftentimes that involves some allocation, some initialization. If you think about creating an object, that means we have to reserve some memory for that object. We have to allocate that memory, say it belongs to this object, and then initialize it, meaning putting the initial data in there. Most programming languages today, that means zero it all out and then run your constructor. And that's how we initialize things. We first zero it out and then run the constructor. And then at some later point, you might decide you're done with that memory. You're done with that file. You're done with that database record. So we may need to be able to destroy it, or just, as they say here, destruct it. So that means it's finalized and deallocated. So deallocated means we take the space back. Finalized means we do any cleanup we need. So we do whatever cleanup we need, and then we take the space back to be used for something else. Okay. So this, in general, this kind of idea that these are the functionality that persistent storage needs to be able to do, means that these four operations, create, read, up, and delete, are really fundamental to any sorts of persistent storage that you're going to run into. Make sense? So if you can learn how to do all four of those things with databases, with files, with whatever it may be, you'll be good. Okay. So in general, when we're dealing with SQL, you might say, well, is there some sort of correlation to what we call the data manipulation language? That's what DML stands for. So SQL DML. There's actually SQL is actually composed of like 3 different languages, which is kind of a confusing thing, especially when you're getting started. SQL is not just one language. Okay, so there's the query language, which we talked about, which is the select statements. Okay, so that's the query language part of it. But we also talk about the DML. This is the data manipulation side. And the third one, which we've already talked about, but we didn't really give it a name, is called the data definition language. Okay, the data definition language is how you create your schemas and your databases and your tables and your indexes, etc., your foreign key constraints, etc. So the data definition language is how you define the schema. The query language is how you query the data. The data manipulation language is how you change or alter the data that's there. So create maps up to the insert keyword. Read maps up to select. Update matches up to update, and delete matches up to delete. Okay, so that's how we kind of do that mapping when we're talking about Crud. It gets kind of interesting here because when we say create is insert, well, in SQL, remember they have both the keyword create and the keyword insert, right? So the keyword insert is part of the DML. The keyword create is part of the DDL, okay? So we use create to create the schema, but we use insert to insert data, okay? That's kind of the difference. Similarly, when we're talking about update, alter is the keyword that you use to manipulate the schema, and update is the word you use to manipulate the data, okay? So there's one verb for manipulating the schema and another verb for manipulating the data. Delete's the same way. Drop is to drop something from the schema, and delete is to manipulate the data. Make sense? So DDL, we've got a create, alter, drop, and this one in the middle would closely be, I think, describe is probably the closest one to that, rather than select. So that's kind of how that maps. So let's talk about those keywords kind of in piece. So select, we talked about that on Friday, is we use select statements to read the data. We can use that to read a single record. We can use that to search the database or generate complex reports. We can do that to do all sorts of reads, whether it's a single record, whether it's all the records, whether it's just some subset of the records. We can do all of that with the select statement. So anything that you need to do that's a read operation, is with the select statement. Cool? It's worth noting that the select statement in a lot of ways can be used inside of any of these other statements. You can actually nest subqueries inside of the other statements to use the select within an insert, an update, or delete. There are ways to do that. That's a little bit beyond what we're going to do here, but it is possible. Okay. So let's talk about, a simple select. Simple select that we talked about there could look like that. Select from, select the first name, the last name, phone number from contacts. Okay, pretty simple query. I'm just getting back those 3 columns from the table. So let's talk about insert, update, delete. So we use the insert, update, and delete statements to write data. Anytime we need to change the data, we're going to use those 3 statements. So let's look at what inserting looks like. Okay. I will clarify that there's a few different ways to write insert in SQL. I'm asking for you to write it a very specific way, and part of that comes out of learned experience. Okay. There are some more loosey ways to write an insert statement, but I really, really ask that you write it this way. Clear? Okay. So you may be familiar with insert statements. This may be a slightly different syntax that you're familiar with. This is the one I want you to follow. Okay. So insert into. Some flavors of SQL, the word into is optional. Other versions of SQL, it is required. So just stick with the idea that it's required, and it will work with everything. Okay. So insert into contacts says we're inserting into the contacts table. So I want to put new records into there. The next part that we see here in parentheses, first name, last name, and phone number. That tells me what columns are you inserting into, and which columns are you going to populate, and in what order you're going to populate it. Tracking with me? Which columns in which order? When you list them here, they don't have to be in the same order that you specified when you created the table. Okay? But the data down here does have to be in the same order as what's listed up here. Technically, this part in parentheses is optional. Most flavors of SQL will allow you to not include it. Please don't be the person who does that, okay? Because what happens is if you don't specify what columns you're inserting into, it just picks the first ones from the table and starts plopping them in. And more than likely, that query might work today. It won't work tomorrow or in a week because databases are rapidly changing. And so what might work today might not work tomorrow is really not self-documenting. Without having this part here, it's very easy for the database to change in a way that you can't figure out what the script was supposed to do, because I don't know what column you were trying to insert into. Does that make sense? Because if we insert a column and we add a column and it's like in the middle, well, it's like, well, that changes what's happening here. Or if I add another column that's required, which oftentimes happens, then, well, this fails because something's missing and it can be hard to work out where that should fit in. Tracking with me? So while this part is really, again, it's considered optional to specify which columns you're inserting into, please don't get in the habit of leaving it out because it will bite you in the butt and bite you hard. It will get you into code where it's like, I don't know what this code was supposed to do. Good luck. I've seen that happen a lot of times. So do include that. The next thing that we have here is this keyword values. I start breaking this up into multiple lines. You can write this all as one line. I find this is kind of the easiest way, the most readable way for me to write this is to break it down here. So values says, after this point, I'm going to give you all the values, all the rows that I want to insert. Okay, that keyword has to be there. Okay, so first, here's the columns I want to insert, and here's the actual values I want to put in. With the insert statement, you can insert one row at a time. You can insert multiple rows at a time. This is the case where I'm inserting multiple rows at once. Okay, which if you can do that, really, really do. You really, really want to. insert multiple rows at a time, that will be much faster than inserting one row at a time. And we're talking about a factor of 10 to 100 times faster to insert the rows all at once rather than inserting them as separate insert statements. That's one of the things we run into pretty quickly. Which also means that the cost of repeating this, like the column names, isn't that big if you're inserting multiple rows at once, especially. Okay, so I've got the first row, Mickey Mouse, and his phone number, right? So you can see the parentheses declaring that this is a row. And we can see, okay, Mickey matches up the first name, Mouse is the last name, phone number matches up. Similarly with Donald Duck and Louis, right? So we'll end up inserting 3 rows with this statement, okay? Now notice the statements, how they're terminated. So for each row, I'm ending the first ones with a comma, the last one I'm ending with a semicolon. You see that? The semicolon says this is the end of the statement. SQL's kind of weird. Again, it's pretty flexible. There are a lot of things that are optional. Semicolons is one of those. Semicolons are completely optional in SQL. You don't have to include them, but please do. But please do. And that's not just for a readability standpoint. There actually are some cases in SQL where it's ambiguous to SQL, whether those are 2 separate statements or 1 statement. Especially because you can include select statements in the middle of other statements. So in some cases, it may look like, here's a statement, here's an insert, oh, there's a select after it. Well, they just put those together if you don't put a comma, a semicolon at the end. Okay, so it's a good habit to be in that practice of putting a semicolon at the end, even if it isn't required.
So do we have any control, like where these are put in the list, or when some by default they just go to the end of the table?
So yes, conceptually they're usually going to end up at the end of the table. That is actually much more complicated. They only go to the end of the table if you are clustering them a certain way. Okay, there's an idea in SQL in relational databases known as clustering. And clustering is how the records are stored on the disk. And by default, things are clustered by the primary key, but most databases allow you to change that clustering, right? So if I cluster by last name, I can do that. It will actually, as it inserts these rows, it'll put them in different places in the file based on what the last name record is. Does that make sense? So the clustering actually controls where these records get inserted into the file itself. Does that make sense?
This seems like it'd be pretty useful for just keeping track of.
It sounds useful. My experience is it's always a bad idea. Okay. It's always made things slower for me to change the clustering.
So does it matter where it does end up in the cluster? Because if we have like the order by and stuff anyways, it's basically how we want it done.
Right. So if you don't order it, then it will be in the order that it's in the file, right? And so that's one of the reasons why you always order it, so that the clustering, whatever the clustering is, doesn't matter. That's one of the many reasons. Okay. The idea behind cluster is actually pretty complicated, but the idea is to put certain records together so that some operations are faster, is the gist of it. The best thing I can advise to you is pretend that your tables, all of the data is randomly ordered. Just pretend that that's the case, okay? And then you won't get hit hard when clustering is a change that you need to make. Got it? Pretend that the data in the table is in a random order. Don't pretend that you're inserting it to the end. That's what gets people into trouble, is they assume that every record is added to the end of the table. But that's not always the case. Okay. So update statement looks like this. It's got a few keywords that go into it. First thing you're going to see is update. Okay. It's going to say update what table. So I'm going to update the contacts table here. The next keyword you're going to see is set. and the last piece is a where. Okay. Now, so set says what data do I want to change? Okay. So here I'm going to say let's change the phone number to this new number. Make sense? So set says what columns you want to change and what do you want to change them to. This is one of those weird cases where this single equals does mean assignment, but this single equals means comparison. In a where clause, it means comparison. In a set, it means assignment. Okay? SQL is kind of weird like that sometimes. So here I'm saying I want to update some contacts. The way I actually read updates maintenance is I always skip over the set and come back to it last. I go look at the where first. Okay. So I say, okay, update the contacts table. Let's look at what the conditions are. Well, the conditions are where the first name is Mickey and the last name is Mouse. Okay. So I want to update the Mickey Mouse record. Okay. And so that's the record I'm going to go find, and then I'm going to change his phone number to new phone number. One word of advice in there, I actually tend to, just like I write my select statements out of order, I do tend to write my where query, my update statements out of order. I'll write the update first, kind of leave this basically as blank as I can with the set, figure out the where, and come back to the set. The other reason you want to do that is this statement, there's a few statements in SQL that are very easy to break and lose all your data. And update's one of them. Okay. Update's one of them where it's very easy to lose a whole lot of data very quickly. Okay. So let's say I do something like this. Update contacts. And I come in here, I'm starting to write, and I say, hey, I want to change the phone number. And I'm in the process of writing these statements, but I say, hey, for somewhere in here, I'm going to set it to null. Okay, so I start writing this out. I haven't written a where statement yet. I have no where clause there yet. I actually hit the little lightning bolt and run that code. Guess what happens?
They update everything to null.
Update everything to null.
The phone number.
Yeah, I was going to say fine, sets all of this back.
Yeah. All of the phone numbers in the contacts table are now null. Huh? That's a big boo-boo. And that's really, really easy to do accidentally. That is so easy to do accidentally. Okay. So you do this and then, oh, we've lost all the data. I hope we had a backup because that's the only way to solve this. If you don't have a backup of your database, that data is gone permanently. And by the way, your backup might take an hour to restore. If you can get a hold of your DB8 that quick to do the backup, and hopefully the backup's not that old. Because the backup might be from yesterday. So things to be very, very cautious about, especially if you're working with production data, right, is it's very easy to accidentally run these without a where statement. If you don't run it without a where statement, it's the entire table. It's the entire table. This is one of those things that drives me mad about SQL that we've not fixed. Because it's written in this order, this is like the default how you start writing. You don't write the where clause until you get there next, right? And that's part of why I do it in that order. Because I'll just like not even write the set statement because I don't want to accidentally run it until I've got some limits on it, right? Because if at least if I accidentally change one record to null, that's one thing. But if I accidentally change all of the records to null, that's a problem. Now, another gotcha with this, remember that in Workbench, If you don't select everything, it runs your entire script. Remember, it only runs the script that you highlight, if you highlight something, right? So I might have a where clause in here. But if I only highlight those 2 lines, it's going to go run just that and update everything without any where on it. Because this is valid SQL. Again, semicolons are optional. It's another gotcha, right? Because semicolons are are optional, that's perfectly valid SQL. Everybody kind of tracking with me there? It's worth noting you can also update multiple records at the same time. So if I want to really be dangerous, then I just also say, let's also lose all the email addresses. But the way you separate multiple sets is just with a comment. I'm going to set this column and set that column. My where clause then can use whatever. It's worth noting that the where clause is the same syntax that you use for select statements. All the same operators. Okay? It's all the same rows of them. At least in this basic version, you're not getting joins and things like that. There are ways to do joins with an update statement, but they're beyond the scope of what we're going to talk about here. Okay? Questions? So that where clause is super, 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 super important. Make sure you have one. Okay? Make sure you're not running an update statement without one. Unless you, for some interesting reason, really do need to update everything.
If we're doing an update like that, would you recommend doing like a separate update statement for doing multiple fields?
It's better to update the fields together in one statement.
Okay.
It's better to do that because it only has to go through the table once. Only has to basically, you think about a loop, it only has to loop through the records once, and that's actually a lot faster than looping through twice. Because I could do the same thing in 2 update statements. It's absolutely faster with just 1. Which of course is not a great thing when you're trying to avoid losing your data. It is worth noting that generally speaking, your database transactions can't, your database operations can't be canceled. If you say, oh, this is not doing what I want to, and you say, oh, I'm just going to close Workbench, yeah, it doesn't matter. The database is already doing the work. So even if you close Workbench, even if you Control-Delete to quickly get out of there, you've already told the database to do thing. It's already working on it. So that's not going to get you. That's not going to save your bacon. There is something to know about in terms of databases. There's commonly something called a transaction. Transaction gives you a way to roll back. Okay, so it's really worth knowing and learning a little bit about transactions. They're really beyond the scope of what you generally see in like a college level course, but they're an important thing to know for the industry. So you may want to read up on those, but the idea with the transaction is you can say, here's some things I need to do, and if anything goes wrong in the middle there, we can roll back, or if it all goes good, then we can commit the transaction. Right now we're just writing very simple statements where the whole operation is one statement. And so inherently those single statements are kind of run in a transaction themselves, sort of thing. Okay. Last up, let's talk about deleting data. So here I'm going to say delete from contacts. It's worth noting that from keyword is often optional, just like insert into. Into is often optional, except in some flavors of SQL. So some flavors of SQL do require the from keyword. Okay. So we're going to say delete from contacts, and where first name is Pluto, last name is gone. So here I'm saying, well, let's delete Pluto from the database. That's it. So just like you saw with an update statement, having where clause, there's also where clause for delete statement. Okay. Same problem applies, by the way. Delete from contacts is a valid statement by itself. If I leave off the where clause and forget to highlight it, it's going to go ahead and just delete the entire table. Say, okay, everything there, I'm just going to throw it away. So again, make sure you have a where clause on that. Otherwise, you're going to lose everything. Especially problematic if you say delete from users. Yeah, all your users are gone. Hope you have a backup. SQL is unfortunately very dangerous with that. It is, you know, it is a language that is much more friendly than what came before, right? In terms of letting it be more English-like and less programmer, like you need to know, need to know a bunch of programming knowledge to write SQL, but it's very easy to lose or pollute or corrupt all your data. It doesn't really put any safeties in place when it comes to update statements or delete statements. It will give you some safeties if you have constraints on your tables. That can help a little bit, especially foreign keys and things like that. It may give you some errors depending on how you set it up, but more than likely, you can't really rely on that.
So you got the delete from context, but you still where wrong? Did you do an error or was it still delete context?
You said without this?
Like you still where wrong? Yeah.
Oh, well then it'll just say, hey, there's a syntax error. Yeah. Yeah, if you leave off like the E, W-H-R-E, then it'll say, hey, you got a syntax error, I can't do this. Right, as long as it sees that. Syntax errors, it'll stop. But if there's not a syntax error, it'll just keep going. Mind you, SQL's an interpreted language. So it might do part of the script and then find a syntax error and stop at that point. Just because there's one syntax error doesn't mean it's not going to run all the code before it. And it generally does. It generally does run all the code until you get to a syntax error. And then it stops. Which is usually worse. Because then part of your script ran and part of it didn't. Okay? Questions? So that's the basics of the Crud statements. As you can see, like, there's insert. Insert's not really too hard to learn, but it does become a bit of syntax. There's your updates, and there's your deletes. Overall, they're pretty easy to write, but they're also pretty easy to screw up, is the two things I want you to see from that. Like, the syntax is pretty simple, but they're also really easy to get wrong. Okay, so there's a group exercise, and what I'm going to do is basically combine this one and the one before it, and have you do both of those things and turn those in today. I think I put the due date formally for tomorrow, so you got today and tomorrow to do that. Try and finish that up. Finish up sooner because you have a lab I want you to get to. So that, but there's some flexibility. Okay? So just like previously, you're going to break up back into your groups. You're going to use that database that you created previously in working with courses and assignments. There's a few statements I need you to write. Okay, so one of those is to insert or add yourself as a student. I also want you to write some statements to create the courses that you're in, as well as adding yourself to those courses. Okay, you need to add yourself to those courses. Well, what does that mean by adding yourself to this course? What record keeps track of, what table keeps track of what courses you're part of?
The course student.
The course student. So you need to insert the course, but also insert into the course student record. Right? Because otherwise you're not actually part of the course. Right? The course is there, but you're not part of it. Write something to update your phone number and your email address with a single statement. Kind of there's a hint. And also then to delete the course and remove all the students from it. Okay. There's a hint here. The order that you do this is going to matter. So what I want you to do is both this exercise and the one from the select queries. So I'm going to pull those two up here. So there's one from the select, there's the select exercise as well as the Crud exercise. So that's the two things I want you to do at this point.